Okay, the question looks like this. N plus 2 over 3 plus n minus 2 over 2 must equal 1. When I look at this equation, I really don't like fractions, so I will multiply by 3 to start with to get rid of the first fraction. Okay, and multiply by the fraction's denominator. So if I do multiply by 3, I have to multiply every term, and I have to multiply both sides, right? To make it balance. So the first fraction multiplied by 3 just looks like that, n plus 2. Because if you times something by 3 and then divide it by 3, the 3's cancel each other. The second fraction, if I multiply it by 3, I need to use brackets to show that the 3 actually multiplies everything on the top line. And as a side, I could have written it like this. Okay, both would be acceptable. However, I kind of prefer to write it like that. In my mind, it just looks a bit easier, but this is not wrong. And then don't forget to multiply the 1 by 3. 3 times 1 is 3. My next line of working is going to be to multiply everything by 2, because I want to get rid of that fraction, so I multiply it by its denominator. Right, don't forget everything has to get multiplied by 2. I suppose I could have wrote there 2n plus 4, same thing. And when I multiply this term by 2, the 2 on the bottom of the fraction disappears. Because if you multiply something by 2 and then divide it by 2, they cancel each other out. And then I would also multiply the 3 by 2, which gives that number. Okay, we're on the home straight really, because we've got rid of the fractions. We've got what's called a linear equation, which means linear just means straight or straight line equation. I'm going to get rid of the brackets by multiplying out everything. 2 times n becomes 2n. 2 times 2 becomes 4. And 3 times n becomes 3n. And 3 times 2 becomes, don't forget the minus. All equal to 6. Lastly, I'm going to collect these n's together. 2 plus 3 of them is 5 of them. And 4 minus 6 becomes minus 2. Must equal 6. Getting very, very close to a solution now. To undo a minus 2, I'm going to add 2. To undo a multiplication by 5, I'm going to divide by 5, both sides. And I would leave my answer as 8 over 5, because 5 doesn't go into 8, so just leave it as a fraction. And here I was, that was my operation here. Sorry, that was simplifying, this was expanding. Okay, the significant difference with this one is x is one of the denominators. Okay, in the previous question we multiplied by both the denominators so we got rid of the fractions. The theory doesn't change. We don't like fractions, we multiply by denominators, even if they are an x. So, to start with, I'm going to multiply both sides. If you do the same thing to both sides, you can multiply whatever you like, or divide by whatever you like, or subtract by whatever you like, or add whatever you like, but as long as you do it to both sides. So, my working here is to multiply both sides by x to get rid of this denominator. Okay, so if I multiply this term by x, I wind up with 2, because I'm like 2 times x divided by x, I'm still got 2. The x's cancel each other out. So on the left hand side I've only got 2. Can you picture that? You multiply by a number then divide by that same number, you wind up where you started. And then on the left side, on the right side, I've got to multiply that side by x as well. And as I keep on saying to you, 3/4 of x is the same as 3 times x divided by 4. That is the same as what I've written down here. And I don't mind which way you do it. Okay? 3x over 4. Again, I've got a fraction in my problem. I want to get rid of the fraction, so I'm going to multiply by the denominator, which is 4. So multiply both sides by 4. 4 2s. 3x divided by 4 times by 4. 3x. 3x divided by 4 times by 4 is still 3x. The 4's cancel. And now I've got a nice simple problem. Divide both sides by 3. I get 8 over 3. Can you do that division? 8 divided by 3? 2 and 2/3. But in algebra we prefer to leave it as a improper fraction like that.